Since the dawn of humanity, we have gazed up at the night sky. We've looked to the stars and the moon with wonder and curiosity. The moon, in particular, has held a special place in our imaginations. It's a celestial companion, a silent observer to the chaos of our world. For centuries, it has been a source of myths, legends, and scientific inquiry. We've written poems about it, told stories about it, and even sent humans to walk on its surface. Yet, for all we have learned, the moon remains a place of mystery. There are places on the lunar surface that we have yet to fully explore, areas shrouded in darkness and veiled in secrecy. One such place is the moon's south pole, a region that has captivated scientists and conspiracy theorists alike. It is a place of extreme conditions, where the sun barely rises above the horizon and temperatures plummet to unimaginable lows. But it is not just the harsh environment that makes the lunar South Pole so intriguing. It's the secrets it holds, the mysteries that lie hidden beneath its desolate surface. In this exploration, we embark on a journey to uncover the truth about the most dangerous place on the moon. The moon's south pole is a place of stark contrasts. Jagged mountain peaks cast long, ominous shadows across cratered plains. These craters, some dating back billions of years, hold secrets to the moon's violent past. Unlike the more familiar near side of the moon, which is tidally locked to face the Earth, the South Pole is a realm of perpetual twilight. The sun hangs low in the sky, casting an ethereal glow across the desolate landscape. Within these deep, dark craters, scientists believe there may be something truly extraordinary: water ice. This ice, deposited by comets and asteroids over billions of years, could be the key to unlocking the moon's secrets and enabling future human exploration. But the presence of water ice is just the tip of the iceberg. There are whispers of other anomalies, strange readings, and unexplained phenomena that suggest the South Pole may hold more than just scientific curiosities. Some believe it could harbor evidence of extraterrestrial life, or perhaps the remnants of a long-lost civilization. The moon's South Pole is not for the faint of heart. It's a place of extreme temperatures, where the mercury can plummet to minus 248 degrees Celsius, minus 415 degrees Fahrenheit, in the shadowed depths of its craters. These frigid conditions pose a significant challenge for both human explorers and robotic missions. The extreme cold can freeze machinery, drain batteries, and make it impossible for humans to survive without sophisticated thermal protection. But the cold is not the only danger. The lunar South Pole is also bombarded by radiation from the sun and deep space. Without the protection of a thick atmosphere like Earth's, the surface is exposed to harmful cosmic rays and solar flares. And then there are the unknowns. The same shadows that hide the moon's secrets also conceal potential dangers. What lurks in the darkness of those craters? What challenges await those brave enough to venture into this unforgiving realm? To understand the mystery of the moon's South Pole, we must first journey back to a time of intense rivalry and technological innovation, the space race. In the mid-20th century, the United States and the Soviet Union were locked in a battle for supremacy in space exploration. Each successful launch, each orbit, each milestone was a symbolic victory in the Cold War. This competition, fueled by political tensions and the desire to push the boundaries of human achievement, spurred an unprecedented era of technological advancement. Rockets were designed, built, and launched with astonishing speed. Scientists and engineers worked tirelessly, driven by the knowledge that their efforts were not just about reaching for the stars, but also about national pride and global dominance. The space race culminated in one of the most iconic moments in human history: the Apollo 11 mission in 1969. Neil Armstrong's famous words, "That's one small step for man, one giant leap for mankind," echoed around the world, marking a pivotal moment in our understanding of our place in the cosmos. The Apollo missions were not just about planting a flag on the moon. They were about expanding the frontiers of human knowledge, pushing the limits of technology, and inspiring generations to come. These missions laid the groundwork for our continued fascination with the moon and the mysteries it holds. The Apollo missions, a series of daring voyages to the lunar surface, stand as a testament to human ingenuity and the insatiable thirst for exploration. From 1969 to 1972, 12 astronauts walked on the moon, conducting experiments, collecting samples, and capturing breathtaking images of the lunar landscape. Each mission brought back a wealth of data, revolutionizing our understanding of the moon's formation, composition, and history. We learned about the moon's ancient volcanic activity, its bombardment by asteroids and comets, and the composition of its regolith, the fine, powdery dust that covers its surface. While the Apollo missions focused primarily on the near side of the moon, they also provided glimpses of the enigmatic South Pole. Orbiting spacecraft captured images of towering crater rims casting long shadows across the lunar surface, hinting at the region's extreme and unforgiving environment. These early observations sparked curiosity and fueled speculation. What secrets lay hidden within those shadowed craters? Could there be more to the moon's south pole than just a desolate wasteland? Even as the Apollo missions were capturing the world's attention, there were whispers of something unusual at the moon's south pole. Some scientists pointed to strange readings from lunar orbiters, anomalies that couldn't be easily explained. These whispers were often drowned out by the excitement of the Apollo landings, but they persisted, fueled by the knowledge that much of the moon remained unexplored. Some researchers speculated that the anomalies could be caused by variations in the lunar surface, perhaps deposits of minerals with unusual magnetic or reflective properties. Others, however, entertained more intriguing possibilities. Could these anomalies be evidence of something extraterrestrial? Perhaps the remnants of a crashed alien spacecraft or structures built by a long-vanished civilization? These theories, while often dismissed as fringe science, captured the public imagination and added to the allure of the moon's south pole. As the Apollo era drew to a close, the moon's south pole remained largely unexplored, a tantalizing mystery waiting to be unraveled. The whispers of anomalies persisted, a constant reminder that the moon still held secrets waiting to be discovered. After the Apollo missions, lunar exploration entered a period of relative quiet. However, the allure of the moon never truly faded, and in the 1990s, a renewed interest in lunar exploration emerged. In 1994, the United States launched the Clementine mission, a joint venture between NASA and the Ballistic Missile Defense Organization. Clementine's primary objective was to test new sensor technologies, but it also carried out extensive mapping of the lunar surface. The spacecraft's instruments were designed to image the moon in multiple wavelengths, providing scientists with a more comprehensive view of its composition and geology. One of Clementine's most significant discoveries was the confirmation of water ice at the moon's poles. The spacecraft's instruments detected the signature of water ice within permanently shadowed craters at the South Pole, a finding that had profound implications for future lunar exploration. The presence of water ice meant that future missions might be able to utilize this resource, potentially enabling longer duration stays on the moon and reducing the need to transport water from Earth. This discovery reignited interest in the moon's South Pole, transforming it from a region of scientific curiosity into a potential resource frontier. Following the success of the Clementine mission, NASA launched the Lunar Prospector in 1998. This small, spin-stabilized spacecraft was equipped with a suite of instruments designed to further investigate the moon's composition, magnetic field, and gravity. One of Lunar Prospector's primary objectives was to confirm and map the distribution of water ice at the poles. Using a neutron spectrometer, Lunar Prospector detected the presence of hydrogen atoms, a key component of water molecules, within permanently shadowed craters at the South Pole. The data indicated that these craters could contain significant amounts of water ice, potentially billions of tons, mixed in with the lunar regolith. This discovery further fueled the notion that the moon's South Pole could serve as a valuable resource for future human exploration. The presence of water ice meant that future missions could potentially extract and utilize this resource for a variety of purposes, including drinking water, oxygen production, and even rocket fuel. the Lunar Prospector mission marked another significant step forward in our understanding of the Moon's South Pole. It confirmed the presence of a potentially game-changing resource and solidified the region's importance as a target for future exploration. In 2009, NASA launched the Lunar Reconnaissance Orbiter, the most sophisticated spacecraft to orbit the Moon since the Apollo era. Equipped with a suite of advanced instruments, LRO's primary mission was to create detailed maps of the lunar surface, paving the way for future robotic and human missions. LRO's instruments have provided unprecedented views of the Moon's south pole, revealing the region's rugged terrain, towering crater rims, and the depths of its permanently shadowed craters. The spacecraft's Diviner Lunar Radiometer experiment has measured temperatures within these craters, confirming that they are among the coldest places in the solar system. LRO's observations have also provided further evidence of water ice at the South Pole. The spacecraft's instruments have detected the spectral signature of water molecules within shadowed craters, confirming the presence of this vital resource. The data collected by LRO has been instrumental in advancing our understanding of the Moon's South Pole. Its detailed maps and observations have provided valuable insights into the region's geology, environment, and potential resources, paving the way for future exploration. As we have journeyed through the history of lunar exploration, it has become increasingly clear that the Moon's South Pole is a region of immense scientific and strategic importance. The presence of water ice, the potential for other resources, and the unique scientific opportunities it offers have made it a prime target for future exploration. Space agencies around the world are now actively planning missions to the lunar South Pole. NASA's Artemis program, for example, aims to land the first woman and the next man on the Moon by 2025, with the South Pole being a primary landing site. These future missions will build upon the knowledge gained from previous expeditions, delving deeper into the mysteries of the South Pole. They will investigate the distribution and abundance of water ice, search for other potential resources, and conduct scientific experiments to unlock the secrets of the Moon's past. The exploration of the Moon's South Pole represents the next chapter in our journey of lunar discovery. It's a journey driven by scientific curiosity, the pursuit of knowledge, and the desire to push the boundaries of human exploration. The quest to understand the Moon's South Pole is about more than just scientific curiosity. It's about unraveling the mysteries of our solar system, piecing together the history of our celestial neighborhood, and searching for answers to fundamental questions about our place in the cosmos. The Moon, our closest celestial neighbor, holds clues to the early solar system's formation and evolution. By studying the Moon, we gain insights into the processes that shaped our own planet and the conditions that gave rise to life. The exploration of the Moon's South Pole is a testament to the power of human ingenuity, collaboration, and the relentless pursuit of knowledge. It's a journey that transcends national boundaries, uniting us in a common goal of discovery. The stakes are high, but so too are the potential rewards. As we venture into the unknown, we carry with us the hopes and dreams of generations past and the aspirations of generations to come. The Moon's South Pole beckons, and we are ready to answer its call. The lunar South Pole stands apart, shrouded in mystery and challenge. It's a realm of extremes, with perpetual twilight and eerie shadows. The sun casts long shadows across a landscape sculpted by cosmic bombardment. Unlike Earth, the Moon is harsh and unforgiving. At the South Pole, these conditions push human ingenuity. Temperatures plummet, and radiation bathes the surface. Amidst these extremes, there is stark beauty and awe. Towering crater rims pierce the lunar sky. Deep within these craters lie pockets of eternal darkness. Scientists believe these depths hold water ice and clues to life's origins. The lunar South Pole is a tantalizing enigma, challenging our understanding and driving exploration. Among the many craters that scar the lunar South Pole, one stands out as a focal point of scientific interest and future exploration: the Shackleton crater. Named after the famed Antarctic explorer Ernest Shackleton, This colossal impact crater stretches over 20 kilometers in diameter and plunges more than 4 kilometers deep. What sets Shackleton Crater apart is its location. Situated almost directly at the lunar South Pole, its interior is cloaked in perpetual darkness, shielded from the sun's rays by its towering rim. These conditions, while extreme, have created a unique environment, a cold trap where volatile compounds, including water ice, have accumulated over billions of years. Data from orbiting spacecraft, including NASA's Lunar Reconnaissance Orbiter, has confirmed the presence of water ice within Shackleton Crater. This ice, mixed in with the lunar regolith, represents a potentially invaluable resource for future human explorers, offering a source of drinking water, oxygen, and even rocket fuel. The exploration of Shackleton Crater is a top priority for future lunar missions. Robotic rovers and landers are being designed to withstand the crater's extreme conditions, venturing into its depths to study its composition, map its icy deposits, and unlock the secrets it holds about the moon's history and the early solar system. Section 3. The Enigma of Peak of Eternal Light. A glimpse into Perpetual Day. Near the lunar South Pole, the Peak of Eternal Light experiences near constant sunlight due to the moon's minimal axial tilt. This sunlight offers a reliable source of solar energy and a unique environment for exploration. The elevated position provides a commanding view and facilitates communication with Earth. However, extreme temperature variations and persistent radiation pose significant challenges. Section 4. The Lunar Regolith, a tapestry of cosmic history. The moon's surface is covered by regolith, a fine, powdery material created by micrometeoroid impacts over billions of years. This regolith contains grains from the moon's formation, asteroid fragments, and traces of the solar wind. At the South Pole, permanently shadowed craters preserve volatile compounds, including water ice. Future missions will analyze the regolith to unravel the moon's formation and the bombardment history of the inner solar system. Section 5. The Dance of Light and Shadow. A world of stark contrasts. The lunar South Pole features extreme contrasts between light and shadow, with temperatures ranging from -50 to -240 degrees Celsius. Sunlit areas offer potential solar energy, while shadowed craters harbor valuable resources like water ice. Future missions must navigate these extremes, requiring specialized equipment and advanced habitats. Robotic rovers and human explorers will face significant challenges in this unforgiving environment. Section 6. Temperature extremes, a test of technological endurance. The lunar South Pole's extreme temperatures, from searing hot to unimaginably cold, challenge lunar exploration. Sunlit areas can rise above -50 degrees Celsius, while shadowed craters plummet to -240 degrees Celsius. Future missions need robust thermal insulation, advanced heating systems, and specialized materials. Human outposts must provide stable environments for astronauts while minimizing energy consumption. Section 7. The Invisible Threat. Radiation's grip on the lunar surface. The moon lacks Earth's protective magnetic field and atmosphere, exposing it to the sun's radiation and cosmic rays. This radiation poses risks to human explorers and electronics, increasing cancer risk and causing malfunctions. Future habitats will need radiation shielding, potentially using lunar regolith or water ice. Spacecraft and rovers must be hardened against radiation, and astronauts require specialized suits and monitoring equipment. Section 8. Water ice, the promise and challenge of a vital resource. Water ice at the moon's South Pole offers potential drinking water, oxygen, and rocket fuel. Trapped in permanently shadowed craters, this ice presents significant extraction challenges. Future missions need innovative technologies for extracting, processing, and storing water ice. Robotic missions will map water ice distribution, while human explorers establish infrastructure to utilize this resource. Section 9. The potential for volatiles. Unveiling the moon's hidden treasures. The South Pole's shadowed craters may harbor volatiles like hydrogen, helium, ammonia, methane, and carbon dioxide. These compounds, delivered by comets and asteroids, could provide valuable resources for future lunar inhabitants. Hydrogen could be used as rocket fuel, ammonia as fertilizer, and methane as an energy source. Future missions will identify and quantify these volatile deposits to determine their feasibility for sustaining a human presence. Section 10. A landscape frozen in time. Clues to the solar system's past. The lunar South Pole's ancient craters act as time capsules, preserving material from the early solar system. Studying the regolith, water ice, and volatiles provides insights into the processes that shaped our solar system. The moon's surface holds clues to the bombardment history of the inner solar system and the distribution of water. Future missions will explore this ancient landscape, seeking answers about our cosmic origins. Section 1. Whispers from the Void. The Allure of Extraterrestrial Theories. The moon's South Pole has been a focal point for theories about extraterrestrial visitation. Some speculate that the region could harbor evidence of alien presence, such as crashed spacecraft or hidden bases. Unexplained anomalies in lunar images fuel these theories, despite most being attributed to natural phenomena. While no scientific evidence supports extraterrestrial life on the moon, the possibility continues to fascinate and inspire. Section 2. Echoes of Ancient Astronauts. The Search for Evidence of Past Civilizations. Some believe the moon may hold evidence of ancient civilizations, particularly at the unexplored South Pole. Proponents point to unexplained anomalies, suggesting they could be remnants of ancient lunar structures. While no scientific evidence supports this, the idea captures the imagination and fuels speculation. The challenge is to rigorously investigate anomalies while remaining open to extraordinary possibilities. Section 3. The Enigma of Artificial Structures. Decoding the moon's geometric anomalies. Pareidolia leads us to perceive familiar shapes in random stimuli, such as lunar craters. Geometric patterns on the moon fuel speculation about artificial structures. Most of these features can be explained by natural geological processes like volcanic activity and impacts. The moon's lack of atmosphere preserves ancient features, adding to the illusion of artificiality. Section 4. The Hum of Hidden Bases. Speculations on Secret Lunar Outposts. Conspiracy theories suggest secret lunar bases already exist, hidden from public view. Theories point to the abrupt cancellation of the Apollo program and potential government collaborations. The South Pole's extreme environment and potential resources make it a prime location for hidden bases. While no credible evidence supports these theories, they continue to intrigue and inspire. Section 5. Magnetic Anomalies. Unveiling the moon's unexplained forces. The moon, unlike Earth, lacks a global magnetic field. However, localized magnetic anomalies, known as lunar swirls, have been observed in various regions across its surface, particularly at the South Pole. These swirls, characterized by bright swirling patterns of lighter-colored material, have puzzled scientists for decades. The origin of these magnetic anomalies remains a mystery. Some scientists believe they are related to the moon's ancient magnetic field, which is thought to have existed billions of years ago before dissipating. Others speculate that the swirls are caused by interactions between the solar wind and the lunar surface, perhaps in areas where the magnetic properties of the regolith are different. The lunar South Pole, with its higher concentration of magnetic anomalies, is of particular interest to scientists studying these phenomena. The region's extreme environment, with its permanently shadowed craters and potential for water ice, could provide clues about the moon's magnetic past and the processes that created these enigmatic features. Future lunar missions, equipped with sensitive magnetometers and other instruments, will undoubtedly focus on studying these magnetic anomalies in greater detail. Unraveling their origins could provide insights into the moon's early history, the evolution of planetary magnetic fields, and the complex interactions between celestial bodies and the space environment. Section 6. Temporal distortion, the possibility of time slips and dimensional rifts. The concept of time travel, once relegated to the realm of science fiction, has intrigued physicists and philosophers for centuries. While the possibility of traveling through time remains theoretical, some speculate that the moon, with its unique gravitational environment and proximity to Earth, could be a key to unlocking this mystery. The lunar South Pole in particular, with its extreme conditions and unexplained anomalies, has become a focal point for theories about time slips, dimensional rifts, and other temporal distortions. Some believe that the region's magnetic anomalies, combined with the moon's gravitational influence, could create wormholes or other space-time distortions that could allow for time travel. Others speculate that the moon's ancient craters, some dating back billions of years, could hold remnants of past events or even parallel universes, accessible through temporal rifts. These theories, while highly speculative and lacking scientific evidence, capture the imagination and fuel our fascination with the unknown. While the possibility of time travel remains firmly in the realm of science fiction, the moon, with its many mysteries, continues to inspire us to explore the boundaries of science and imagine the impossible. Perhaps one day, our understanding of the universe will advance to a point where we can unlock the secrets of time and unravel the true nature of reality. Section 7. The unexplained disappearances, vanished missions, and missing data. The history of space exploration is fraught with both triumphs and tragedies. From the Apollo 1 fire to the Challenger and Columbia disasters, the inherent risks of venturing beyond Earth's atmosphere are undeniable. But what about the missions that seemingly vanish without a trace, leaving behind more questions than answers? Conspiracy theorists often point to lunar missions, particularly those targeting the enigmatic South Pole, as evidence of a cover-up, suggesting that governments or other entities are concealing the truth about what lies hidden on the moon. They cite instances of lost communication, missing data, and unexplained anomalies in mission footage as evidence of something sinister at play. While most, if not all, of these disappearances and data anomalies can be attributed to technical malfunctions, human error, or the limitations of technology at the time, some remain unexplained, fueling speculation and casting a shadow of doubt over the official narratives. The lunar South Pole, with its extreme environment and challenging terrain, is a particularly unforgiving destination. The region's extreme cold, radiation, and communication challenges make it a hostile environment for both human and robotic explorers. It's plausible that some missions may have encountered unforeseen circumstances that led to their demise, leaving behind limited or inconclusive evidence. Section 8. Government cover-ups, conspiracy theories, and the suppression of truth. Conspiracy theories have been an integral part of human society for centuries, offering alternative explanations for events and phenomena that challenge the official narratives. The realm of space exploration, with its inherent mystery and potential for groundbreaking discoveries, has been a fertile ground for such theories. One persistent theory suggests that governments around the world, particularly those with advanced space programs, are engaged in a massive cover-up of extraterrestrial life or ancient civilizations on the moon. Proponents of this theory claim that evidence of alien bases, crashed spacecraft, or ancient structures is being suppressed from the public to prevent widespread panic or to control access to advanced technologies. The lunar South Pole, with its extreme environment, unexplored terrain, and potential for resources, is often cited as a focal point for these alleged cover-ups. The theory suggests that governments are secretly exploring this region, perhaps in collaboration with extraterrestrial beings, and concealing their findings from the public. While there is no credible evidence to support these claims, the idea of government cover-ups and hidden agendas continues to resonate with some, fueled by distrust of authority, a desire for alternative explanations, and the allure of the unknown. Section 9. The Power of Belief. why we're drawn to the unexplained. Humans have an innate desire to understand the world around them, to seek meaning in the chaos and find patterns in the random. This quest for understanding often leads us to embrace beliefs and explanations that provide a sense of order and control, even in the absence of concrete evidence. The moon, with its long history of myths, legends, and scientific exploration, has been a blank canvas onto which we project our hopes, fears, and beliefs. From ancient tales of lunar deities to modern conspiracy theories about alien bases, we imbue the moon with meaning that reflects our own cultural biases and desires. The lunar South Pole, with its extreme environment, unexplored terrain, and unexplained anomalies, is particularly susceptible to such projections. The lack of concrete information allows our imaginations to run wild, filling the void with explanations that resonate with our existing beliefs and satisfy our craving for the extraordinary. Whether it's the allure of extraterrestrial life, the possibility of ancient civilizations, or the belief in government cover-ups, our fascination with the moon's mysteries reveals a deeper truth about ourselves. Our need to believe in something beyond the mundane, to find wonder in the unknown, and to imagine a reality more extraordinary than we can currently comprehend. Section 10. The Quest for Answers. Separating Fact from Fiction. The moon, despite decades of scientific exploration, remains a celestial enigma, harboring countless mysteries beneath its desolate surface. The lunar South Pole in particular, with its extreme environment, unexplored terrain, and unexplained anomalies, continues to captivate our imaginations and fuel speculation about extraterrestrial life, ancient civilizations, and government cover-ups. While the allure of the unknown is undeniable, it's crucial to approach these theories with a healthy dose of skepticism and a commitment to scientific rigor. Extraordinary claims require extraordinary evidence, and the burden of proof lies with those making such claims. The quest for answers requires a multifaceted approach, combining scientific exploration with critical thinking and a willingness to challenge our own biases. Future lunar missions, equipped with advanced instruments and guided by a spirit of scientific inquiry, will play a crucial role in unraveling the moon's mysteries and separating fact from fiction. As we venture further into the cosmos, it's essential to remember that the greatest discoveries are often those that challenge our preconceived notions and expand our understanding of the universe and our place within it. The moon, with its enduring mysteries, serves as a constant reminder that the quest for knowledge is an ongoing journey, driven by curiosity, skepticism, and an unwavering commitment to the pursuit of truth. The legacy of Apollo paving the way for future exploration. The Apollo missions revolutionized our understanding of the moon's composition, history, and potential resources. The data collected paved the way for subsequent robotic missions and new technologies. The discovery of water traces sparked interest in larger deposits at the poles. The Apollo program's influence on lunar exploration continues to this day. The lessons learned inform current and future expeditions. The Apollo program reminds us of human ingenuity and international collaboration. As we return to the moon, Apollo's legacy will guide our steps. Advances in technology and understanding will unlock the moon's secrets. In 2009, NASA's L-Cross mission dramatically impacted our understanding of the moon's south pole. The mission involved crashing a rocket stage into Cabeus crater, followed by a spacecraft analyzing the debris plume. The impact created a bright flash and a debris plume visible from Earth. Instruments detected water ice, confirming its presence at the lunar South Pole. This discovery was a watershed moment, highlighting water ice as a valuable resource for future lunar exploration. India's Chandrayaan missions. Exploring the moon's secrets. India's space program, called ISRO, is a big deal in space exploration. Their Chandrayaan missions show how advanced India is in space and how much they want to learn about the moon. Chandrayaan-1, launched in 2008, had special tools that mapped the moon's surface in amazing detail. It gave us important information about what the moon is made of and where the ice is hiding at the poles. This mission even crashed a probe into the moon on purpose. Scientists looked at the dust cloud it made to see if there was water in it. Chandrayaan-2, launched in 2019, wanted to learn even more. It had a lander and a rover to explore the moon's south pole. Sadly, the lander crashed, but the orbiter is still going around the moon, collecting information. GAP-2S. These Chandrayaan missions are a huge accomplishment for India's space program. They show how good India is at space exploration. The information these missions gathered has helped us understand the moon better, and it has also inspired lots of future scientists and engineers in India and all over the world. As India keeps exploring space, the Chandrayaan missions will be remembered as super important steps in their journey to the stars. China's been doing some amazing things on the moon lately. Their Chang'e missions show just how good they are at space stuff. One of their biggest wins? The U-2 rover. It landed on the moon back in 2013 with the Chang'e 3 mission. U-2's name comes from a Chinese story about a jade rabbit that lives on the moon. Cool, right? GAP-2S. This rover had special cameras, radar that could see underground, and tools to study what the moon is made of. It drove around for weeks learning all about the moon's rocks, minerals, and what's under the surface. U-2's trip was a huge deal for China. It proved they could send robots to the moon and control them. What U-2 found out helped us understand how the moon formed, how it changed over time, and what kinds of cool stuff might be there. Everyone got even more excited about going to the moon. GAP-2S. Because of U-2, China tried even harder things like landing Chang'e 4 on the far side of the moon, the side we never see from Earth. That was in 2019. No one had ever done that before. As China keeps exploring, we'll always remember U-2. It started a whole new chapter of discovery on the moon and maybe even beyond. While government-funded space agencies have traditionally led the way in lunar exploration, the 21st century has witnessed a surge in private companies entering the space industry, driven by technological advancements, decreasing launch costs, and a renewed interest in exploring the cosmos. The Google Lunar X Prize, announced in 2007, challenged private teams to land a rover on the moon, travel 500 meters, and transmit high-definition images back to Earth. Although no team claimed the grand prize by 2018, the competition had a lasting impact on the space industry. It fostered innovation, collaboration, and competition, demonstrating the potential for private enterprise in space exploration. Robotic missions have become increasingly sophisticated, enabling us to explore the moon and other celestial bodies in greater detail than ever before. However, these missions face numerous challenges, pushing the limits of technology and requiring innovative solutions to overcome the harsh realities of the space environment. One of the primary challenges is the extreme temperature variations on the lunar surface, which can swing hundreds of degrees between day and night. Robotic explorers must be designed with robust thermal insulation, advanced heating systems, and materials that can withstand these extreme conditions without becoming brittle or malfunctioning. Communication delays due to the vast distances involved pose another significant challenge. Commands from Earth can take several seconds to reach a lunar rover, making real-time control impossible. Robotic explorers must be equipped with a high degree of autonomy, relying on onboard computers and sensors to navigate, make decisions, and avoid hazards. The harsh radiation environment of space poses a constant threat to sensitive electronics. Robotic explorers must be designed with radiation-hardened components and shielding to protect their delicate instruments and ensure their longevity. Despite these challenges, robotic missions continue to play a vital role in lunar exploration, providing a wealth of data and paving the way for future human missions. As technology advances, we can expect even more sophisticated robotic explorers, capable of venturing further, exploring deeper, and unraveling the moon's mysteries with even greater precision and detail. Section 7. The Human Element, the Risks and Rewards of Crewed Missions. While robotic missions have provided invaluable data and insights, there's no substitute for the human element in exploration. The ability to observe, adapt, and make decisions in real time, coupled with the human spirit of curiosity and the drive to push the boundaries of knowledge, makes crewed missions an essential aspect of lunar exploration. However, sending humans to the moon presents significant risks and challenges. The lunar environment is harsh and unforgiving, with extreme temperatures, radiation, and a lack of atmosphere. Astronauts must be protected from these hazards with advanced spacesuits, life support systems, and habitats designed to withstand the rigors of the lunar surface. The psychological and physiological effects of long-duration spaceflight are also a major consideration. Astronauts must maintain their physical and mental health in isolation and confinement, coping with the challenges of microgravity, radiation exposure, and the psychological stress of being far from home. Despite these risks, the rewards of sending humans to the moon are immense. Crewed missions allow for real-time decision-making, adaptability, and the ability to conduct complex scientific experiments that would be difficult or impossible for robotic explorers. The presence of humans on the moon would mark a significant step forward in our exploration of the cosmos, inspiring future generations and expanding our understanding of our place in the universe. Section 8. The Future of Lunar Exploration. Unveiling the Secrets Yet to be Told. The moon, once thought to be a barren and lifeless world, has revealed itself to be a place of surprising complexity and scientific intrigue. As we stand on the cusp of a new era of lunar exploration, the future holds immense promise for unlocking the moon's secrets and harnessing its potential to benefit humanity. Future missions, both robotic and crewed, will continue to explore the lunar South Pole, mapping its resources, investigating its unique environment, and searching for clues about the moon's history and the early solar system. The establishment of a sustainable human presence on the moon, a key goal of many space agencies and private companies, would mark a pivotal step in our journey to become a multi-planetary species. The moon offers a wealth of resources, including water ice, rare earth elements, and helium-3, a potential fuel for future fusion reactors. Harnessing these resources could not only support a lunar base, but also provide valuable materials for Earth and fuel further exploration of the solar system. As we venture further into the cosmos, the moon will serve as a stepping stone, a testing ground for technologies, and a source of inspiration for generations to come. The future of lunar exploration is bright, filled with the promise of discovery, innovation, and the expansion of human knowledge and presence beyond the confines of our home planet. Section 1. The Next Giant Leap. Setting our sights on the lunar South Pole. The lunar South Pole is now a primary target for space agencies and private companies, driven by scientific discovery and resource utilization. NASA's Artemis program aims to land the first woman and the next man on the moon by 2025. Private companies are also developing technologies to support future missions. These efforts aim to establish a permanent foothold on the moon, paving the way for future exploration. Establishing a lunar foothold, the challenges and rewards of a permanent base. The establishment of a permanent lunar base, a long-held dream of space enthusiasts and science fiction writers, is now within the realm of possibility. The discovery of water ice at the lunar poles, coupled with advances in robotics, 3D printing, and other technologies, has made the prospect of a sustained human presence on the moon more feasible than ever before. A lunar base would serve as a hub for scientific research, resource utilization, and further exploration of the solar system. Scientists could conduct long-term studies of the moon's geology, environment, and potential for harboring evidence of past life. The base could also serve as a testing ground for technologies and life support systems needed for future missions to Mars and beyond. However, building and maintaining a lunar base presents significant challenges. The moon's harsh environment, with its extreme temperatures, radiation, and lack of atmosphere, requires innovative solutions for habitat design, life support, and radiation protection. The logistical challenges of transporting materials and supplies from Earth are also significant, requiring advancements in space transportation and the development of in-situ resource utilization techniques. Despite these challenges, the rewards of a permanent lunar base are immense. It would represent a giant leap forward in human exploration, expanding our presence beyond Earth and paving the way for a future where humanity becomes a multi-planetary species. Section 3. Unlocking the Moon's resources, a stepping stone to the solar system. The Moon, once thought barren, is now seen as a treasure trove of valuable materials. Water ice at the lunar poles offers drinking water, oxygen, and rocket fuel. But water ice is just the beginning. The Moon also harbors rare Earth elements and helium-3 for fusion reactors. Sustainable resource use could support a lunar economy and reduce Earth's resource reliance. The lunar South Pole is a prime target for resource exploration. Future missions will develop technologies for resource extraction and utilization. The Moon could become a hub for space-based industry and further solar system exploration. Utilizing lunar resources presents opportunities and challenges. Sustainable practices are essential for long-term viability. International cooperation and clear legal frameworks are crucial for responsible resource management. Section 4. The Scientific Payoff, Deepening Our Understanding of the Cosmos. The Moon offers a unique platform for scientific research, providing insights into the history of our solar system and the fundamental laws of physics. The lunar South Pole, with its extreme environment, is a particularly enticing target for scientific exploration. Scientists are eager to study the composition of lunar water ice, which could hold clues about the early solar system. The Moon's ancient craters could contain pristine samples of the early solar system. The Moon's lack of atmosphere makes it ideal for astronomical observations. Telescopes on the Moon could peer deeper into the universe, revealing new galaxies and planets. The scientific payoff of lunar exploration promises to deepen our understanding of the cosmos. Each mission brings us closer to answering fundamental questions about the universe's origins and the potential for life beyond Earth. Section 5. Inspiring future generations, the enduring legacy of lunar exploration. The exploration of the Moon inspires generations, igniting imaginations and fostering a passion for STEM. The challenges and triumphs of lunar exploration showcase human ingenuity and collaboration. Establishing a sustainable presence on the Moon engages and inspires new generations. Lunar missions captivate audiences, sparking curiosity and wonder about the universe. Technological advancements from lunar exploration benefit industries and improve lives on Earth. Studying the Moon deepens our understanding of Earth and addresses challenges like climate change. The legacy of lunar exploration is measured in scientific discoveries and the inspiration it provides. Venturing beyond Earth pushes human potential and inspires wonder, shaping humanity's future. Section 1. The Moon's Siren Song, a tapestry of mystery, promise, and the unknown. The Moon, once a symbol of distant beauty, now reveals captivating complexity and secrets that could rewrite our understanding of the solar system. The lunar South Pole, with its extreme environment and hints of water ice, promises groundbreaking discoveries. Future missions, driven by curiosity, will seek answers about the Moon's history and the potential for life beyond Earth. The Moon's Siren Song is irresistible, drawing us back with the allure of the unknown. It is a call to adventure and a testament to the human spirit of exploration. The journey has just begun.